So next session I'm very excited for this session. It's about artificial intelligence. So we have uh, with us Rajesh. So just a little bit about Rajesh. Rajesh is, we are honored to, honored to introduce Rajesh. He is accomplished security architect and consultant with over 3 decades of experience. So Rajesh expertise spans networks, software, system engineering, sec DevOps, and machine learning. His collaboration with cross-functional teams have delivered innovation solutions to complex challenges across diverse industries. Rajesh's commitment to knowledge sharing and awareness raising in STEM, security, privacy, technology, fallacies is commendable. And currently, he is driving groundbreaking research in the intersection of 5G, IoT, data fusion, machine learning, and cognition, aiming to revolutionize secure connectivity and cognitive infrastructure. So thank you so much, Rajesh, for joining us. It's a really pleasure, and we'll be very grateful to you for you to be here. Thank you so much. Over to you. Rajesh, you're not able to hear. Rajesh, you're on mute.
Okay. Are you guys able to hear me?
Yes.
Sorry about that. Thank you, Satish, for really those wonderful words. That's very kind of you. I'm not that accomplished, so there's a lot to go. Do you guys see my screen?
Yes.
Okay. So essentially, one of the reasons I called it, to AI or not to AI, is essentially two things that it came to my attention. One was Elon Musk, having stoked the fear of AI, especially saying that, hey, you know what, we need a moratorium on artificial intelligence. It got me thinking, why is he saying it? Why does he want to say that, we need to have a moratorium on artificial intelligence? Is it the fear of what Sam Altman had just mentioned to the congressional hearing at that time, that we have got to be cautious here and blah, blah, blah. And he just said, oh, you know what, we make the mistakes when the stakes are low. But all that said, I think people should be happy that we are little scared. That in itself started to, make me think. And then Musk calling for a moratorium. Was he that he was already feared because he didn't exploit that technology and put that forward? Is it for that or something else? And on top of it, there is Lee Kun, who stated that the models are not capable of any kind of thinking, but nonetheless, they are dangerous. And I'm like, wait a second, isn't that a paradox? Isn't that ironic that people would say, hey, wait a second, at one time, I'm hearing that AI is beneficial, and I'm actually building things related to artificial intelligence. But then at the same time, I'm claiming that, no, wait a second, it's dangerous. Now, that reminded me of Hamlet. I'm not sure how many of you have read Hamlet, but in that there is the, if I remember correct, it's Act 3, Scene 1, where Hamlet goes, to be or not to be, that's the question. Whether the nobler in the mind to suffer the siblings and arrows of outrageous fortunes, or to take arms against a sea of troubles. He goes so on, and then ends, be all my sins remembered. Now, essentially, when you read that from Hamlet, it gives you kind of themes that you can group and look at it from all this hype that we are having with artificial intelligence. One theme you can put is about doubt and uncertainty. The second one is about life and death. And thirdly, to me, it's just madness. Probably one of the things that I can talk about here is that maybe we are asking the wrong question. Is it that it's one wrong presupposition in that, when we talk about life and death, about two options we have, that is to either commit suicide, or we are going to be looking at the suffering of the slings and arrows of fortune. Or maybe there's a third way. And that's what got me thinking. Maybe there is a third way. A third way, an option where we can continue to live while decreasing the sufferings, not only by ending life, but by altering it. We can fundamentally alter it if necessary, and then thereby decreasing the suffering in life rather than destroying it. And yes, there may be an answer to it. And maybe one of the answers that I thought about is, while this philosophical discussion was great, then how does it really work in the industry? And this is where I go to the very first part where I was introduced. That's the standard operating procedures. Any way you work, there is a standard operating procedure. Whether you're working in the energy industry, pharmaceuticals, the government, Google, doesn't matter. Any industry you go to, there is a standard operating procedure. And one of the things here, when we are considering this presentation, is there is a standard operating procedure. And in any standard operating procedure for a presentation, there is who performs what role. And in this case, we have three distinct roles. Satish and the CSA chapter from San Francisco, they are the host, and their role is very well defined. It is about their role where they are the organizers. They provide us the platform to present, and I'm the presenter. But then, as an organizer, Satish and his team have taken a big risk. So they have to do a risk assessment. Is this person capable of talking? Is it worth bringing the person in, talking about anything they need to motivate their people, to provide any input to what they are doing and help them grow? So in other words, that risk assessment will also have a set of rules. And then they assess it. And that's where the governance, risk, and compliance comes in. They look at it. They look at it whether, hey, you know what? This is the risk I have. How do I govern the risk? And how can I make this compliant to what I want to do, and therefore govern it accordingly? And here I do see a complexity. Complexity comes because now I have three kinds of interactions. The interaction between me and the host and the audience and me. So right there, if you take it mathematically, it is the sum of n numbers. So in this case, there are 6 interactions that can be possible. And that interaction between people creates complexity. And that's where, when we are talking about AI, for example, the feature set and the domain knowledge, this is where it becomes important. And this is why many of the time people ask about domain knowledge, because that's a critical aspect. If you don't understand the domain, it becomes very difficult to learn the domain and then look at the feature engineering of it. So this complexity, how can we manage it? And that's the mop. This is another thing I learned as I was going through the various industries. What's a mop? It is exactly what you would use from your washroom. You mop the thing away, the floor away. It's the method of procedures. This is one of the ways that we can handle complexity that is particularly inherent, especially in our data centers, in data processing applications, in high-performance computing systems. I'm not going to go into high-performance computing systems, but just know that there are 2 different ways to deal with it today. One is the high performance, which is more related to static information. And then there is the streaming analytics that is related to the streaming part of the systems, which is more dynamic. In here again, we are expecting that I had started with an agenda. And then you go through like a typical presentation. I didn't do any of that. So I changed the map. And when I changed the map, what happened is that as human beings, we get confused, and that creates complications. And this is where everything starts. Everything breaks down because of complications. Have you ever heard that, the operation was successful, but the patient is dead? It is because of complications. Complications arise because you break the rules. And when you break the rules, it means there is an intermittent fault. And that is where I started with machine learning. This is way back in 91. I had an interesting problem. I was studying the induction motors, and I was trying to build my first microcontroller. Um, Essentially, without going into details, they were using what are called the thyristors in those times. And I was trying to think about another way to do something, because the factory that we owned, it's a chemical factory, that centrifugal pumps could become quite problematic, and those pumps are expensive. And second problem that I got was related to what we it was part of what we call the Karnataka Electricity Board, and that was part of the hydroelectric plant. And I came to know through the new government electric factory that, hey, you know what? We have an intermittent problem. That intermittent problem could be catastrophic, and these are incipient faults. These incipient faults can occur anytime, and they are in the continuous range. So when we are talking about continuity, we are talking about time series. And more importantly, these time series, the waves that we are talking about, we deal with it through Fourier analysis. But sometimes we need to convert that, make data acquisitions, and then convert them into, or digitize them as they call it today, and study the data. We are losing information. This is something we need to understand. When you are converting the signals to data, there I am having information loss. Now, how will that impact? There could be problems. This is where security comes in. Now, that data loss, is it going to impact my security? What I mean by security here, is there a kinetic attack possible because I oversaw a part of the data? Or is it part of information security? But more, when I'm working in critical infrastructures, it's related to safety. When I'm talking about safety, it is about safeguarding the loss of life, property. And in many cases, this is where my SOPs come in. Now, when there was a paper we wrote to the PHM conference about how resilience
Rajesh,
can.
sorry to interrupt. Quick time check.
Yeah.
We have 3 more minutes.
3 more minutes. Okay, sure, I can go forward. So essentially, to understand how safety can be impacted, we look at the data. And one of the first things we did was backpropagation. Backpropagation is just an algorithm. There are, this is basically the one that would help train us, build a model, and then use the algorithm again to build the model, where we have various different types of algorithms, like whether it's linear regression, Bayes theorems, based, or support vector machines, gradient boosting, so on and so forth. But the key thing is training. Now, it is this training that helps us do the prediction part, and this training requires data ops. So this is right there. I have spoken about 3 different dimensions we need to think about. One is the data. The second is feature selection and training. The third is your algorithm development. And finally, the model versioning or model. Now, all of these 4 are required to do your predictions. And if this prediction is what your solution is requiring for, this solution will have a life cycle. That life cycle, from conceptualization to the eventual end of life, will contain all the life cycles of the 4 dimensions, and will also need to be governed, managed across every bit of that life cycle in all the dimensions. And every one of them is complex. Now, if you don't have proper governing structures in place, basically the company is screwed. One of the things that I can highlight about this is way back in 2013, I believe, the then model creator from Facebook basically said, we set up the model But then eventually we came to realize that we could not control the model. So you see, it develops a life cycle of its own. And we can basically get to the point where we have an AI ops, a ML ops, a SecOps, a AI SecOps. You can basically get all kind of hype. But eventually, what is that pipeline? It is not one single pipeline. There's multiplicity of the pipeline. I'll not go into a lot of detail on this, but eventually our solution is either about automation or autonomy. Now, but then when we talk about autonomy, it is about intelligence. It's about heuristics. It's about cognitive infrastructures. And for that, we need to understand the DIC. Now, the DIKW is essentially about data, information, knowledge, and wisdom. The knowledge I have is data for you. So knowledge is not free. Why? Because the data that you have has to get matched with certain patterns that will be there to get us some relevant information. That information needs to be related to certain contexts and learned and to get knowledge. So thereby you are basically not having knowledge which is free, but that knowledge that needs to be earned. And then you get wisdom over time, recognizing the knowledge you have, and thereby you know when you need to speak, when you need to shut up. And that's kind of wisdom. And all of this to say that you have over time, you're working with data. Each one has that data. Can I basically screw that data up? And that's where the adversarial systems come in. So there are more than just one way to do it. I can, because of the way the data is got obtained, supply chain attacks is possible, side channel attacks are possible. There are many different ways of getting into this. I can even, if I'm in the IoT sector, for example, if I'm doing optical fibers, I can introduce rogue devices into those fiber systems and thereby send spurious signals into the system, bring down that network. So this is another big thing. This is, I'm still, just covering the surface. All of this to say, till now, we talked about, hey, you know what? It was useful. It helped me solve the incipient fault identification problem. But at the same time, I'm now talking about, hey, you know what? Did I get my data correct? Is that data what I'm having right? Now, this gives me that paradox we talked about in the to AI or not to AI. And that paradox is kind of becoming important because it's still telling me, do I solve or not to solve with AI? Which one do I choose? Should I just ignore AI? For example, one of the paradoxes I can talk about is the Roko's basilic. This is just a simple thought experiment similar to the Schrödinger cat, right? The experiment basically is a statement that if I have a benevolent artificial super intelligence in the future, would be, incentivized. And then I create a virtual reality simulation to torture anyone who knows about its potential existence, but did not directly contribute to its advancement or development to incentivize, and said advancement. Now, here I am basically talking about or making a statement which seemed to contradict itself. It is like, hey, I have put in my security structures, but is that system secure? So you see, this is, by the way, what I stated is a Moore's paradox. These are basically paradoxes in the sense that seem to contradict itself, but nonetheless, they are true. So how do we work? So what is our future now? And that's why we have to AI or not to AI. From probably one of the best movies depicting AI, that's Stanley Kubrick's 2001 A Space Odyssey, down through the memory lane of Terminator, Terminator 2, so on, the Aliens, and then the Matrix. And most recently, it is the Mission Impossible Dead Reckoning Part 1. Is AI the Armageddon that we have? Or is there something really useful in it? What is that paradox that we have? In my opinion, mine only, I believe we are overhyping the destruction. There is usefulness, but the key question we need to ask is not can we build it? Do we need to build it? Is there another way to solve the problem, which is simpler? And that is something we need to think about. And that's the future we have. Just because we have a hammer does not mean we should see a nail everywhere. And that's where I end my talk. And I'm open for any kind of questions. And I would like to refer to the Canadian question period. You can ask all the questions you want, but don't expect an answer.
That was very insightful. It was really. Any questions, anybody?
No, I think that was very interesting. Rajesh, I think you've given me a couple of actually project ideas and a very good idea way ahead for me to build a good social profile for cybersecurity and the work that I do. I will have questions. I think, in the interest of time, I'll just, are you okay to be reached out on LinkedIn? And, if I have any follow-up questions and,
Sure.
any guidance.
For sure.
Thank
I
you.
use LinkedIn more as a contact and messaging point. So yeah, please. And if it is
Okay.
something that requires us to go by email, I'll just shift to email. So
Mhm.
nobody's on that.
Sure. Thank you. Yeah. Thanks for
You're
your
welcome.
insights.
Thank you so much, Rajesh, for being here and then giving a very good insight on whether using AI or not to AI. I mean, it makes really sense whether we need to. It's very important to think in that direction, is what I feel. So yeah, with that, we'll close the session. There is one part where we go through what is for the next session, what is the topic. But since we are over of time, request everybody to send it to me by LinkedIn or through CSA. I'll try to find a speaker and then we'll try to have that session. Thank you so much, everybody, for attending. It was really two great, wonderful sessions which I witnessed. Thank you.
Yep. Thanks, Satish. Yep. Thanks, everyone.
Thank you, everyone. Appreciate it. Bye.